Alright, so this week we are going to learn how to graph quadratic functions when the equation is written in standard form. So remember, standard form looks like y is equal to ax squared plus bx plus c. So if an equation is in standard form, there are some steps that we're going to want to take to actually graph it. So I've written out all the steps. There are 6 steps total. And anytime you have an equation that is in standard form, like the one I've given to you in example 1, you're going to want to follow these 6 steps to graph it. So the very first step is to find the vertex. So remember, whenever we graph a parabola, there's always going to be that minimum or that maximum, that lowest or that highest point that we call the vertex. And so one of the key points in graphing our parabolas is actually just finding that vertex. So remember, we write the vertex as a point in the form of hk, where h is the x value, k is the y value of the point. And we can actually use a little formula to help us find the vertex. X equals negative b over 2a. So the x value, or h, of that point is going to be equal to negative b over 2a. So x equals negative b over 2a. And we get b and a from our standard form of the equation. So when y equals x squared minus x minus 6, a would be 1, b would be negative 1, and c would be negative 6. So x is equal to the negative of negative 1 over 2 times 1. So x is equal to negative of negative 1 is positive 1, and 2 times 1 is 2. So x is equal to 1/2, or 0.5. So the x value of our vertex is 1/2. Now to find the y value of our vertex, we just take whatever we found x to be and plug it back into our equation. So here I have f of negative b over 2a. That just means plug whatever you found in for x into the function, f of x. So we would have y is equal to 1/2 squared minus 1/2 minus 6. So y is equal to, let's see, 1/2 squared really just means 1/2 times 1/2 minus 1/2 minus 6. So y is equal to 1/4. 1 times 1 is 1, 2 times 2 is 4, minus 1/2 minus 6. And now we have a bunch of fractions that we need to subtract from each other. We'll put this one over 1. So I'm going to change all of the denominators to 4. So I'm going to have to multiply this 1/2 by 2 over 2, and this one by 4 over 4. So we're going to have y is equal to 1/4 minus 2/4 minus 24/4. So y is equal to 1 minus 2 is negative 1, minus 24 is negative 25/4. So negative 25/4. So our vertex is at 1/2 negative 25/4. Now what about our axis of symmetry? So our axis of symmetry is just always equal to whatever the x value of our vertex was. So if I know that the x value of my vertex is 1/2, then I know that my axis of symmetry, my AOS, is just x equals that value, 1/2. Now for step 3. For step 3, we need to find the x-intercepts. And there are multiple ways we can find x-intercepts that we've learned how to do so far this year. We can use factoring, or we can use the quadratic formula. So what we want to check out first is this equation factorable? So for y equals x squared minus x minus 6, actually the first thing we need to do when we find x-intercepts is plug in 0 for y. So we should have 0 equals x squared minus x minus 6. So is this thing factorable? Are there factors of 6 that add or subtract to give us negative 1? Well, I know x times x is x squared. 2 times 3 is 6. And then what if I add 2 and subtract 3? Is negative 3x plus 2x going to give us negative 1x? Yes. So factoring does work, so I don't need to use the quadratic formula. And we just set each factor equal to 0 and solve for x. So x plus 2 equals 0. And x minus 3 equals 0. Subtract 2 to both sides, so x equals negative 2. Add 3 to both sides, so x equals 3. So that tells me that I have x-intercepts at 3, 0 and negative 2, 0. Remember, the y value of all x-intercepts will always be 0. So that's how I know I have the point 3, 0 and negative 2, 0. All right, step 4. So step 4 is a little new. When we find the y-intercept of this parabola, well, anytime we have a y-intercept, we know the x value will always be 0. So if the x value is 0, we can just use f of 0 to find that y value. That means that y is equal to x squared minus x minus 6. We're just going to plug in 0 for x. So y is equal to 0 squared minus 0 minus 6. So y would be equal to negative 6. That means that we have a y-intercept at 0, negative 6. Okay, now we're ready to start graphing. So I've provided for you a graph that's already pre-labeled, so we don't have to take the time to label it. The scale's labeled, the x and y axes are labeled for us. We're ready to start graphing. So what we want to graph then are the things we found in the other steps. We found our vertex, we found our x-intercepts, our y-intercepts, our axis of symmetry. So let's plot those things. So remember, our x-intercepts were at what, negative 2, 0, 3, 0. So negative 2 and 3. Our y-intercept is at 0, negative 6. And then our vertex is at the point 1/2 and negative 25/4. Our vertex is at 1/2 and negative 25/4. Well, what does 25/4 mean as a point? So I'm actually going to find the decimal of 25/4. So 25 divided by 4 is 6.25. So this is really, what, 0.5 and negative 6.25. So 0.5 would be between 0 and 1, and then 6.25 is just under that negative 6. And then we know that our axis of symmetry goes through that point. This is our vertex. So our axis of symmetry is just the horizontal line that goes through x equals negative 1/2. We want to make sure it's a dashed line. This is my axis of symmetry, x equals 1/2. Okay, so I'm starting to see the shape of a parabola here. I've got a point here, I've got a point here, I've got my vertex, and I've got a point on the right side. So because we know that our axis of symmetry divides our parabola perfectly in half, we can reflect our y-intercept across the axis of symmetry. So we can take that negative 6, 0, negative 6, sorry, and just reflect it over. Okay. Now, step 6 is if we need to find more points on the parabola, we can. And I just suggest that you use a table. So for example, if I want to know what the parabola does between my y-intercept and this x-intercept, I could plug in the x value that's in between them. So do you see how this x value is 0, this x value is negative 2. Negative 1 would be between 0 and negative 2. So I'm going to plug in negative 1 for x and find the y value of that point so I can plot it. And then between this point and 3, this is an x value of 1, this is 3, we could plug in 2, just to see what the parabola does between there, those 2 points. Okay, let's go ahead and plug in negative 1. So we're just going to plug this into the original equation. Y equals x squared. I'm going to look up here to see what the equation was. Minus x minus 6. Minus x minus 6. So we're just plugging in -1 for x. So y is equal to -1 squared is 1. The negative of -1 is 1. Minus 6. So y is equal to -4. So we're going to plot the point -1, -4. Then we're going to plug in 2. So y is equal to 2 squared minus 2 minus 6. So y is equal to 4 minus 2 minus 6. Y would be equal to 2 minus 6, which is -4. So 2, -4. And then if we wanted to, we could also plug in the x value of 4 and the x value of -3 just to see where those points would fall. But I think I'm getting a clearer picture here. So this half of the parabola follows this shape, and this half of the parabola follows this shape. And we have a pretty good picture of what this parabola would look like. So we found the graph of this parabola by following a couple steps. 6 steps, actually. The first thing we did was we found our vertex, and then we found our axis of symmetry. Then we found our x-intercepts. Then we found our y-intercept. And then we found some extra points. We reflected the y-intercept, and then we plugged in a couple of x values to find these 2 extra points as well, so we could get a super clear picture of what our parabola would look like. Now let's move on to example 2. So in example 2, you have the equation y is equal to x squared minus 4x minus 12. So what I'd like you to do is to do each step on your own, and then after you do each step, we'll check our work together. So you're going to find the vertex in step 1, find the vertex, HK, go ahead and press pause, and then press play when you're ready to check your answer. Remember, you're using -b over 2a to find the x value, and then plug that in to find the y value. Go for it. So when you did x equals -b over 2a, y equals x squared minus 4x minus 12 is our equation. A would be 1, b would be -4, c would be -12. So plugging those values in, x would be the negative of -4 over 2 times 1. So x is equal to 4 over 2. 4 divided by 2 is 2. So the x value of your vertex is 2. Now to find the y value, you just plugged in that x value into the equation and simplified. So we're going to have 2 squared minus 4 times 2 minus 12. So we're going to have 4 minus 8 minus 12 is equal to -4 minus 12. So y is equal to -16. So our vertex is at 2, -16. And hopefully that matches what you found. Now find the axis of symmetry. Go ahead and press pause and then press play when you're ready to check your answer. So the axis of symmetry is just x is equal to whatever the x value of your vertex was. So x equals 2 is our axis of symmetry. Now it's time to find the x-intercepts. Y equals x squared minus 4x minus 12. Make sure you plug in 0 for y. And then you can find your x-intercepts by either factoring or using the quadratic formula. So go ahead and press pause on the video and then press play when you're ready to check your work. So this equation is factorable. It factors to x minus 6 times x plus 2. And then x minus 6 equals 0. X plus 2 equals 0. Add 6 to both sides, x equals 6. Subtract 2 from both sides, x equals -2. So your x-intercepts that you found should be at 6, 0 and -2, 0. Alright, so now you need to find the y-intercept. So to find the y-intercept, you're just going to plug in 0 for x. So go ahead and press pause on the video, and then press play when you're ready to check your work. So we should have y is equal to 0 squared minus 4 times 0 minus I wrote plus, my bad. Minus 12. So y is equal to negative 12. So we have an x-intercept, or sorry, a y-intercept at 0, negative 12. And hopefully that matches what you found as well. So now we need to plot these points. So I'm going to plot my x-intercepts first at x equals 6 and x equals negative 2. We have our y-intercept at 0, negative 12. And then we have a vertex at 2, negative 16. So let's see, 2, negative 16, 13, 14, 15, it'd be like there. All right, and then our axis of symmetry is just that horizontal line, vertical line, excuse me, that goes through x equals 2. Here's my vertex, here's my axis of symmetry, x equals 2. Now we're going to reflect our y-intercept over the axis of symmetry. So it's 2 spaces away on the left side. So we know that the point on the right side will also be 2 spaces away from the axis of symmetry. And then we want to find some other points just to help us get a clear picture of the graph. So I'm going to plug in an x value between, 0 and negative 2. So I'm going to plug in negative 1. Then I'm going to find a point between, I guess, between 4 and 6, which would be 5. Then just for fun, let's go ahead and plug in negative 3 and 7. So why don't you pause the video, find all those y values, just plug in these x values, find those y values, and then press play when you're ready to check your work. All right, y is equal to, I gotta remind myself what the original equation is, x squared minus 4x minus 12. X squared minus 4x minus 12. There we go. That'll help me get my work done here. So y is equal to negative 1 squared minus 4 times negative 1 minus 12. So y is equal to 1 plus 4 minus 12. Y would be equal to negative 7. Hopefully that's right. You guys aren't here to correct me. So, and then if we plug in 5, y is equal to 5 squared minus 4x, 4 times 5, minus 12. So y would be equal to 25 minus 20 minus 12. That would be 5 minus 12, which is negative 7, which makes sense because we would just reflect that point anyway. So 5, negative 7. And then just for fun, we're going to plug in negative 3. Y equals negative 3 squared minus 4 times negative 3 minus 7. So y is equal to 9 plus 12 minus 7. Y is equal to 21 minus 7, which would be 14. So we're going to be off the graph just a little bit up here. And then if I plug in 7, I should also get 14. Let's see what happens. Y is equal to 7 squared minus 4 times 7 minus 7. So y is equal to 49 minus 28 minus 7. Which is 14. Yep. So 7, 14. There we go. And now we have a clear picture of what our parabola is doing. If we just draw on the curve on the right side, and then draw on the curve on the left side, there we go. We have a beautiful parabola. So on your Delta Math homework, you're going to have to find points on a parabola for a given equation, and then you're just going to plot those points on Delta Math. And once you have enough points plotted, Delta Math will like sketch in the curve for you. It's pretty cool. So shoot me an email if you have any questions, or I'll see you on office hours on Wednesday. Talk to you guys later. Bye.